Hi, today's lesson's on theorems about roots of polynomial equations. So one of the key things here is the rational root theorem. This actually helps you guess what the roots or zeros may be of this. So an example, I know that you can read the words yourself, but basically, let's say I have a polynomial that is 2x cubed plus 4x squared plus 5x plus 4. So what we do here is this is our p and this is our q. And so what we do is we list all the factors of p and q, and then we do every single possibility with it. So for example, the factors of q, which is 2, would be 1 and 2. The factors of p would be 1, 2, and 4. So now what we do is we do the plus or minus of every single one of them. So I like to do this in order. So I go plus or minus 1 over 1. Plus or minus 1 over 2. Plus or minus 2 over 1. Plus or minus 2 over 2. Plus or minus 4 over 1. Plus or minus 4 over 2. And now this is all of the possibilities put together, but it can be simplified. We know 1 over 1 is just 1. We also know that positive 2 over 2 is also 1, so we don't have to worry about that one. We have 1 plus 1 half, plus or minus 1 half, excuse me. Plus or minus 2 over 1 is just 2. And we know plus or minus 4 over 1 is 4. And plus or minus 4 over 2 is just 2, so we have repetition, so we're done. So in other words, if they ever repeat, just write one of them, and you can just check these. So if we take a look at this, I put the graph here just to help us out. It says from the graph that 4 is a zeroth function. Without plugging it in, can you verify that? Yeah, the answer is you can tell just by where it crosses the graph, but you can also know that the rationals, if you do the factors of 4, which would be 1, 2, and 4, and we know 8 is 1, 2, 4, and 8. If we notice that 4 is 4 over 1, so it is a possible solution. That's pretty much it. Go ahead and try this problem. Now this brings us to the fundamental theorem of algebra, which basically says that if you have a polynomial with a degree bigger than 1 and it equals 0, it has exactly n solutions of the complex numbers. So in other words, you can have 5 solutions. They don't have to be real. They could be real, imaginary, radical. It doesn't matter. So for an example, if you have something like x to the 5th, it has 5 solutions. That's it. So whatever the degree is, that's how many solutions you have. And also can have multiplicity. So in other words, repeats count. So if you have something where it says x minus 2, x minus 2, that has a multiplicity of 2, well, that still counts as 2. So for example, let me give you an example. So this has 3 roots. So it has 3 x's, so this is going to be an x to the 3rd, meaning it has 3 solutions, even though the roots are -3 and 2. But 2 has a multiplicity. So the multiplicity counts in this fundamental theorem of algebra. All right, let me go ahead and show you the process of finding all the roots from nothing. This is very tedious, it's very complicated, but it's good to see. So first thing we do is we use the rational root theorem to find all the possibilities. So doing that, you can do that on the side, but basically you get all your roots are plus or minus 1, plus or minus 2, plus or minus 1/3, plus or minus 2/3. So knowing all that, now what we got to do is use synthetic division just to plug trial and error our way to figure this out. It is very, very, very tedious. Luckily, I did all of it for you already for this one. So we get -1, we go 3, 4, 2, -1, and -2. And if you want a shortcut for this, go on the computer, put this into a graphing software, and you'll see where it crosses the x-axis, and then you know it crosses at -1. And then you could do synthetic division from there. So doing that real quick, we get -3, we get 1, we get -1, 1, -1, -2, and we get 2, which is 0. And you know you did it correctly when it's 0. If you guess the wrong one, you won't get 0, and you have to start all over again. So it's best to use graphing software to help guide you a little bit. Now, keep going. Since we not down to 3, we can't use the quadratic formula until we get to 3 numbers. We have 4. So we're going to have to do synthetic division again. So bring down the 3. Now, which one works? I trial and error, or you can do graphing software, like I said. It doesn't matter. But basically, you get 2/3. Now, to do 2/3, you divide by the bottom number and multiply by the top. So this would just be 2. This gives us 3. This would give us 2. Gives us 3. Gives us 2, which is 0. And now we're down to 3, 3, 3. So now we can just use quadratic formula. This is our A, B, and C. So -3 plus or minus square root of 3 squared minus 4 times 3 times 3 all over 2 times 3. So, and that gives us -3 plus or minus over 6, which ends up being, all this is -27. So you get plus or minus 3i radical 3 if you simplify it. And now we reduce it, so we get, what would that be? -1 plus or minus I radical 3 over 2. And now we list the rest of the zeros, which are 2/3 and -1. And there's all of our zeros, roots, whatever you want to call them. That is the process you have to go through. It is very time consuming and tedious. Go ahead and try one. Hint, use the answers to guide you. Since these all have ones, I'd try 1. Now, how can we write polynomial functions from some given complex solutions or complex roots? So there's a rule that says that if you have an I, its conjugate is also an answer. And the reason is because of the quadratic formula, basically. But they always show up together. So if we take a look at this, they have these 2 roots, right? So automatically they have 2 minus 5i and -2i. They have the conjugates are part of it too. So how can we do that and write a quadratic function from that? This is another, if you know your shortcuts, it saves you a lot of time, which I will demonstrate right now. So first things first, I'm going to go ahead and write the 2i. So I'm going to write that as x plus 2i, x minus 2i. And then I'm going to rewrite this one as x minus 2 minus 5i, and then x minus 2 plus 5i. If you want to know what I'm doing, is basically I'm doing the opposite. So this is minus 2i is the positive 2i, the positive 2i is the negative 2i, and these are the opposite of that. So minus 2, and I just changed the sign of these ones in between. If you notice, they're in a certain form. They're in a difference of squares form. Because of that, we can use shortcuts. So x times x is x squared. 2i times -2i is -4i squared, which would be plus 4. And if you notice, this is in the same form. Look at this part right here and this part right here. We have a difference in squares. We have this and this and these. They're the same here with the difference in between. So we can do the same exact thing. So I'm going to do x minus 2 squared plus 25. And then from there, we can expand this out So x squared plus 4. We get x squared minus 4x, and it'd be plus 4, but plus 4 plus 25 is 29. And now from there, we're going to go ahead and distribute the whole thing. So we're going to go step by step, all that stuff. And if you do that, you get x4 minus 4x cubed plus 29x squared plus 4x squared minus 16x plus 116. And our final answer would be x4 minus 4x cubed plus 33x squared minus 16x plus 116. And that is the process you have to go through for these problems. They are quite extensive. Go ahead and try this problem. Okay, we can do the same thing with radicals. So same story. This would be 3 plus radical 7, and this would be negative 4i. And we know it's a degree of 4 because we have 4 of these. So I'm not going to bore you too much, but I do want to show that method. So x minus 4i, x plus 4i. The reason I do that first is because it's a single term. And then x minus 3 plus square root of 7. And then x minus 3 minus the square root of 7. And so basically what we get is x squared plus 16. And this one we get x minus 3. The difference is because there's no I, it's going to be minus 7. So that's the part you got to be careful with. And then of course expand this, x squared plus 16. And then you get x squared minus 6x plus 9 minus 7. And we get x squared plus 16, x squared minus 6x plus 2. And then from there, what you can do is go ahead and just distribute that. I'll trust that you know how to do that. So it's x4 minus 6x cubed plus 18x squared minus 96x plus 32. And that is how you do that. Go ahead and try this problem.